thanks again for having me at Python Web Conference. Spoken here a few times before, and it's always a great event. So thanks for having me back. So hi, went over this already, but I'm Scott, and I love to fix bugs, like genuinely love to fix bugs, like so much so that I created a company, Corgibytes, where I focus exclusively on helping teams make improvements to their code bases. This involves fixing bugs, paying down technical debt, writing tests, improving CI/CD pipelines, all that sort of stuff are other things we do. And in addition to all that other stuff, we also help teams upgrade their dependencies. But for years, while we thought the dependencies were important, we didn't really push our clients super hard to upgrade. We would point out when there was a security vulnerability, and depending on the criticality of that vulnerability, we would really enforce that things needed to be updated. But just being out of date in general wasn't really something that we pushed hard on. And then in 2017, I saw this happen, this article, and this kind of major news event. So Equifax, which is in the US, is an organization that helps with, helps figure out from your credit history whether or not, there are, oh, I see somebody asked if the stream dropped, hopefully not. But in the US, Equifax helps keep track of people who are using credit and whether or not their creditworthiness is good. So this helps with everything from applying to a credit card to getting other services such as signing up for utility or things like that. So when we look at this vulnerability and why it happened, the vulnerability that was exploited was not in code that the Equifax team maintained directly. The vulnerability was actually, vulnerability that was exploited was in a library that they were consuming, specifically the Apache Struts library. And I would like to say that this is probably a very super well-meaning team. Want to kind of point out that in my opinion, everyone's doing their best when they're working on projects, and so fully feel that this team was doing their best. But the vulnerability that was exploited could have been fixed and avoided by just upgrading the library that had the vulnerability. The day the vulnerability was announced, a newer version of that library was available and could have been upgraded to. And that fix was available for 2 months before the data breach happened. So, that's certainly something that we should keep in mind, especially as we have security vulnerabilities or other things. But it really did kind of, looking at this event, kind of got me thinking well, why does this happen? Why do dependencies get out of date and kind of stay out of date? And so fear is definitely a big component. Fear is one of the reasons why we let our dependencies get out of date. We're afraid that if we upgrade a library that we're using, that it's going to introduce a failure and something might break. It might not be something we really feel like we have time for. Updating a library isn't always top of mind. And that's often really influenced and affected by the priorities that are set for us by our leadership, and just kind of what we're thinking about in general. And often that prioritization is influenced by kind of the perceived difficulty in performing these upgrades. So if people think oh, it's going to be really difficult, it's going to be really challenging, then this is something that's going to get deferred and not worked on because of that, because it might introduce a bug, it might cause a failure, and your customers might be affected. And I think largely, and probably what I suspect is the biggest cost is that this problem is invisible. It's invisible to the people who are working on the code bases. It's invisible to leadership. How bad things are is not something that we have a lot of visibility into. We might think that they're pretty bad, but we don't really have a lot of tooling and a lot of ways to kind of have conversations about how bad things are, how bad they've been, and how bad they might get in the future. So dependency freshness as a concept is one of the ways that we can start talking about the problem. And Dependency freshness is a term that was coined by Joel Cox in a paper called Measuring Dependency Freshness in Software Systems. The link to it is down at the bottom of this slide. And it really kind of puts forward this idea that the more up-to-date your dependencies are, the fresher your software system is. So the fresher the dependencies are. Think about it as like a best buy date on something you might get at the store, or fresh, the date that you might have on a bag of potato chips to let you know, how long the contents of the bag will stay fresh. Something along those lines, something like that. I also like to think about it as like brushing your teeth. And the goal for brushing your teeth is to have minty fresh breath, right? So we want our breath to be fresh. And we can also kind of, think about that in terms of our software. So we want our software to be fresh. And the longer it's been since you've updated your dependencies, the less fresh your breath is. And similar to brushing your teeth, you're not going to brush your teeth every single minute. That would be overkill. It would cause other problems. But it is something that would be good to do, every now and then, maybe once a week. Hopefully you're brushing your teeth more than once a week. If there's any dentists on the line, I feel like, I should say it's something you should be doing, once or twice a day. But I don't know that keeping your dependencies up to date, needs to be done quite that often. Some of us don't brush very well, and we're going to have consequences for that. We don't perhaps brush very regularly, and we're going to have consequences for that. And, it's similar for software systems. There are consequences for having dependencies that are out of date. The consequences that we experience kind of differ based on the audience, and kind of whether or not you're a developer, or whether, you're kind of, outside the development organization in other parts of the organization. For developers, the consequences that tend to happen is that the dependencies become harder to work with. So if there's a library in your project that you're using, this library, if the version you're using is significantly out of date, finding the documentation for the version you're using is going to be hard. Finding a blog post or the docs for that particular version might be hard to come by. If you happen to find a blog post for how to use that library, it's likely going to be talking about the version that was the latest when the blog post was written. So you have to look and see when the blog post is written, whether or not those features are available in the version that you have. And if the problem that you're encountering has been solved in a later version of the library, then you might be frustrated because you're not able to use that extra version. Support is also lacking. So if the version that you're using is significantly out of date and you find a bug, the chances of the bug getting fixed in that old version is probably pretty small. For organizations in general, one of the bigger impacts is developer productivity. For all the reasons we just mentioned, the developers are having to do extra work, and that extra work costs time, and time costs money. It also introduces significant security risks. So the further out of date library is, the greater the chances that a security vulnerability will be found or has already been found. And if a vulnerability does get found and is exploited, there's going to be a public relations fallout, and you might have loss of customer trust. So your customers may stop trusting that your product is safe to use as a result of things just being out of date. A dependency freshness measure that I really like is called LibYear. And I think LibYear is something that's easy to measure. It's easy to compute. It's easy to describe, easy to visualize. And I really think it helps facilitate discussions. And one of the best ways that I've seen for kind of communicating what LibYear is this little cartoon that they have on the libyear.com website that really kind of, talks about this scenario before you start using LibYear and after you start using LibYear. And before using LibYear, you don't really have much in terms of a way to have a conversation about how good or bad a project or a library is. But after you start using LibYear and thinking about dependency freshness, it does give you this language and this way to compare projects that you're working with. So again, why using LibYear? Easy to compute. It distills the dependency risk. So the risk of how out of date your project is, it reduces that to a single number, which makes it easy to communicate, how bad things are. And it provides even greater value when the numbers are graphed over time. So when you start to see how things have changed throughout the life of the project, you really start to get a sense for how risky things have been and figure out whether or not you want to improve based on that. If you wanted to measure LibYear manually, you can look at how to do so for a single package. So you take the release date of the latest version, you subtract from that the release date of the version you're currently using, get that value in number of years, and that's the LibYear for that specific package. And then for your entire project, you can get a total LibYear value by just adding all of those scores together and get the number of years out of date your project is. There are automated tools to help you measure this. There is one for the Python ecosystem. It's just called LibYear. You can install it with pip install LibYear, and it gives you a command line tool that you can use to pass it a requirements.txt file and generate the LibYear for the project. So here's an example of doing that with PySpider, which is a website crawling application that has been updated in quite a while. So it ends up being a pretty good candidate for looking at this. And here we can see the LibYear that was computed this morning for this project using the LibYear program. And in total, it's 120 LibYears out of date, almost 121 LibYears out of date. And then so how would you go about measuring this if you're interested in doing so over time, if you wanted to see kind of how values change over time? Because while the LibYear program will give you like how things currently are right now, something it doesn't do is let you see, how well the team has been doing or how well the project has been doing over time, or how changes might be happening to the ecosystem over time. Dependency freshness is a technical debt measure that will continue to get worse as the project hasn't been made, as changes have not been made in the project, which makes it pretty unique when it comes to technical debt measures. With most technical debt measures, they only get better or worse if you make a change to the system. So you can think about complexity or other forms of technical debt, and those will really only get worse if you make a change to the system, if you add a commit. Whereas dependency freshness will continue to get worse as newer versions of the libraries are released. So at Corgibytes, we've built a tool called Freshly to help compute these values and show them over time. You can find more information about it over at github.com/Corgibytes/Freshly, or head to freshly.io or freshly.app. Here is what the freshly.io website looks like. This is where you can kind of play around with the proof of concept that we've put out. It scans public repositories, and it has support for Python projects with requirements.txt files. So let's look at that same PySpider example, but this time looking at a graph. So here's the project total LibYear and how it changed over time. And here we can see that when the project was first created back in 2015, early 2015, the project total LibYear was at 0. And this is true for most projects. When we create a brand new project, we grab the latest version of the dependencies that we're working with, and things are doing great. And if we look over time, for much of this project's history, the LibYear wasn't really all that bad. But then at the end of 2019, early 2020, there was a huge spike. So, what really kind of contributed to this huge total spike, and what might have been going on in the community at that time? So we can look here and we can see the individual packages that were being used by PySpider. And we see that a lot of the packages that it was depending on all got updated at the same time. And I suspect this is because of Python 2.7 reaching end of life. And a lot of packages that were out there either updating themselves so that they could support, so they could be used in Python 3x, or updating to drop support for Python 2.7 and getting rid of some of the support that they had once Python 2.7 had reached end of life. But there was this kind of like network effect that caused a lot of dependencies to get updated all at once. Let's also take a look at a project that's a little more active. So there's Netbox, which helps with keeping track of systems on the network. And here we can look at the maximum LibYear. Instead of looking at the total like we looked at before, we can also look at the maximum. And here the project's been doing a pretty decent job. So for much of the project's history, the total or the maximum of any one package has been out of date has been kept under 2 years. That's pretty decent. I think a threshold of a year is best, but 2 years really isn't bad. And we can also look at the individual packages and see what might be contributing to that now. What might, are there any outliers and what's causing problems? And we can highlight and take a look and see that this JSON schema package is out of date and has been out of date for a little while, but it wasn't always there. It was introduced as a dependency in early 2022, and so why might that be the case? And we can take a look at the requirements.txt file and see that it was added as a workaround for a particular bug. So it could be that the project, until that bug is fixed, can't update to a version that's newer than that. But it would be a good idea for the team to monitor that bug, and as soon as that bug is gone, update things so they can get rid of that dependency. So I want to talk a little bit more about Freshly's status. Right now, it's very much in the proof of concept phase. The demo is posted at freshly.io. It's live, and it, like I said, it supports collecting metrics for public repositories. Our current focus is on developing support for analyzing private repositories and making it easier to add new language ecosystems. So that's what we're currently working on. We have some work done in that direction, and we've built out support for Java using that new approach. We've yet to add support for other language ecosystems yet. Freshly's future and its mission and vision is to help illustrate the financial risk of deferring software maintenance and continuing to do so. And ultimately, the vision that I'd like to see is that tools like Freshly aren't needed anymore, because we've hit the point where dependencies can be upgraded automatically, and in that we can do so safely. So this idea of like automatically keeping libraries up to date, it's definitely something that's within our reach as a community, as software developers. We do have to be wary about supply chain attacks. So the idea that someone could intentionally introduce a security vulnerability into a new version of a library, and that version might have a vulnerability in it. So it's not always the best idea to just blindly upgrade to the latest version of a library when it comes out. But it is a really good idea to keep an eye on how out of date things are and establish those thresholds as a team that you don't want to go over. So maybe for a single package, you don't want a single package that's more than a year out of date, or you don't want your project total to get above a 10 or something along those lines. So you can establish these limits, monitor them, and act accordingly. The next steps that we're going to follow for Freshly is to build out support for private repositories. We want to add additional metrics. There's a metric that we've been working on that we haven't built into the tool yet, but we want to build one that considers security risk. So it really takes into account how many libraries have security vulnerabilities, how critical those security vulnerabilities are, and kind of reduce this to a composite number that teams can use to communicate how critical something should be updated. And then also want to add security vulnerability information to the graphs themselves. So like the graphs that I showed, I'd like to add other graphs that communicate security risk in addition to just how far out of date something is. also be to show how many security vulnerabilities each of those libraries has and the criticality of those vulnerabilities. If you're interested in getting involved, you can head over to Corgibyte, github.com/Corgibyte/freshly. And we can certainly use help adding more metrics and adding support for computing other metrics. There are other dependency freshness measures. The paper that I referenced before mentions a few other dependency freshness measures. Some of the other dependency freshness measures that are out there look at the version numbers and kind of assumes a SEMVer, a semantic versioning approach to working with dependencies, and it uses that as a way to communicate out-of-date dependencies. And so that's something that's definitely worth taking a peek at. We also want to add support for more ecosystems and more dependency formats. So if there is a language ecosystem that you'd like to see added, or there's another way of computing or way of keeping track of dependencies, so like in the Python ecosystem, using a pip file or some other approach, or having dependencies defined in setup.py, those are things that aren't supported by Freshly at the moment, and there's not really good tooling support for that in other tools, such as the LibYear tool that I referenced before. It pretty much only works off a requirements.txt file. So those are problems that certainly need to be solved in the community in order to collect this information. So that's something that definitely needs doing. But kind of the big thing that I want to kind of leave everyone with is this idea that keeping dependencies up to date and having this happen automatically, so we don't need a tool such as Freshly, or we don't need individual command line tools such as the LibYear command line tool. It's possible. It's within our reach. There are tools already available, such as Dependabot, that can help us do this. Tools like Dependabot, and there's another one called, I totally just drew a blank. I don't know what it's called, but I know there is a competitor to Dependabot, that Renovate is what it's called. Renovate will also open up pull requests for your project, and Dependabot is very GitHub focused. So if your team is using GitLab or something else for hosting your source code, then you can look at using Renovate. But having this is achievable. Having things get updated automatically and keeping libraries up to date and helping avoid these security vulnerabilities, it's definitely within our reach. So go out there, take a peek at how out of date things are, talk with your leadership about getting time and getting resources, and look out in the community and find ways to get help, upgrading dependencies. If you have a big dependency like Django, for example, and you're on an older version of Django that doesn't have support anymore, there are places that can help with that. So thanks a bunch. I just realized that I went through that a little fast, and so hopefully people have questions, and we've got plenty of time to answer them. If you'd like to get in touch, this is my contact information. Corgibytes is one of those organizations that could help you upgrade dependencies. So if this is something that your team is struggling with, and you're not sure how to tackle it on your own, please get in touch. This is something that we could definitely help you out with. And thanks a bunch for coming to the Python Web Conference.